This is the second video that I'm going to be doing for Unit 1 worksheet, looking at the data analysis questions, and hope you'll find it useful. Now we have this question which is related to pressure and volume. We have at high pressures a real gas does not behave as an ideal gas. Now you haven't really had any experience with this, so it's probably going to be a little bit beyond you, but we will look at the basics behind this analysis, and I think you'll find that useful. So if you can just not worry too much about this idea of ideal gas, real gas, but we're just going to concentrate on using the formula, looking at our data and doing some data analysis. We won't do the very last question because that's a bit beyond it, but I think you will find some of the things are useful. So firstly, looking at the graph, we have got this. It says in A, draw a line of best fit for the data points. Now again, as I said before in the last video, you need to do this with a ruler. I'm going to do it freehand, which is probably not going to be so good. But the idea would be that you'll try to get your line where these points are lying on either side of the line. So let me see if I can manage to do this. I probably won't do a very good job, but we will try. So I'm going to go something like that. Oh, it wasn't too bad. So you can see there that I've got my points on either side of the line. I'm sure you'll do a better job than I will. That would give you your 1 mark there. Then it says use the graph to determine the values of the constants A and B in the equation. Now it's important that you are familiar, as we discussed before in the last video, with the equation of a straight line. So mx plus b, one needs to identify and be able to work with this. We see that our y in this case is our PV, that's our y, our m is our b, that's our slope, and our x is the p, x is p, and the b actually corresponds to the a. So when it says the constant a, we need to find the b, which is the y-intercept. So that's this point over here. Now one needs to estimate it. It's important that you pay attention. Let me just erase this. I think you've seen that. That should be fine. It's important that you take note of these values, these multipliers. So this, every value here is actually times 10 to the 2. So it's read and see. Now what is the smallest square? That's actually just 1. So this is going to be around about 12.6. 12.6. So it's going to be 12.6. But don't forget to put the times 10 to the 2 and to also put the unit. That's going to be Newton meters there. Put that in. Now this is quite accurate, 12.6 for a best fit line, and all the values that we've been given that seem to be there are like to 2 significant figures. So probably doing this as to 2 significant figures, I could write this as 1.3 times 10 to the 3 would be probably more appropriate for that. In finding the constant b, this is the slope. Now you'd want to use as much of the graph as possible. I would tend to use the whole graph, so do that across there and down there. Again, you'd be using a ruler to do this, so it's nice and neat and accurate. This over here would be your that would be your change in your horizontal, and this over there would be your change in your vertical. Your B would equal that, and I will just give you a result, and hopefully you should get somewhere between 1.0 to somewhere probably 1.2, and this is all times 10 to the -5. Now why is that? Well, because you see here you've got the 10 to the 6 and you've got the 10 to the 2. Now when you divide this out, it's going to be, you're going to be getting the 10 to the 2 divided by the 10 to the 6, which will be 10 to the -4, but when you bring it down to this value here, it works out to be about 10 to the -5. So make sure that you include those values in there. Your units will be, the units that you'll have will be Newton meters divided by this over here, which is going to be this is going to be your pressure, which is Newton meters to the -2. The newtons cancel, and so you're going to have meters to the 3, which makes sense because we can see that when you divide the two, you've got a PV divided by a P, your pressure cancels, and you're left with the volume. So that will be your value there. Going over the page to the next page, I'm not going to spend too much time on this. State the value of the constant B for an ideal gas. This is all a little bit beyond you at the moment, but for an ideal gas, your pressure times your volume is equal to a constant. So you would have this equation, PV is equal to A, and therefore your B for an ideal gas would be 0. And then I'm just going to do this one over here. The equation PV is equal to A plus BP is valid for pressures up to 6. Determine the value of PV for nitrogen gas at a pressure of 6 times 10 to the 7 pascals. Now you just use your formula that you got. You got your PV is equal to A plus BP, and you put in your values that you got for A and B. You take this value for your pressure and put it in there, and you'll get your result. Even if you made a mistake with A and B, even if you made a mistake with that, but you use those values that you got, you would still get credit for these 2 marks over here. This one we will leave for the moment. We'll come back to that sort of problem later on. Okay, thank you very much.